Okay, gentlemen, today we're working on 4.2, day 2 of 2. Quick get ready, review some questions here. What is a root? We covered this in the learning goals recently. So what is a root? It's the value of the variable that makes an equation true. So it's basically the value for the variable that makes left side equal right side, or the expression equal a certain value. So left side has to equal right side. What does solve means? Solve means to find the value of a given variable in an equation. Okay, so to solve means to find the root, basically. And what is the root? The root is the value for the variable that makes the equation true. This question number 3 is actually pretty important. Do you check your answers to the homework questions, and how often? I'm hoping you'll say that you check every time you do, a few questions. You go to the back of the book, or you have a sticky note at the back of the book and you check your answers. Because if you're just doing the homework and not checking, you could be doing all the work wrong, and your homework checks will come out as yes, yes, yes. But then when it comes to testing, you'll find that you're making errors, and it's because you need to check your homework all the time. Again, not every single solitary question, but do a few, check in, especially if you're confident with the material. Then do all of number 1, A, B, C, D, then check the answers. If you find you're making a common mistake, then that's a great trigger for you to remember, when you're doing a test or another question. Okay, I always make that mistake. I got to watch out for that now. All right, evaluate this. Sometimes when you're evaluating questions like this, we know BEDMAS is involved, but it's also important, or it's a convenient way to make sure you follow BEDMAS, is to use brackets. Notice here I'm leaving the operation out, the subtraction. By the way, if you look at the completed handouts on Edsby, you'll see that I've got many hints and notes for you there. So you might want to pay attention to the video and then copy the answer key from Edsby later, because it's a great one with very good color coordinating and tips and tricks and hints. For today, I'm just going to go through this a little bit more quickly so you get the lesson, the gist of it, and then again, copy the handout from Edsby, okay? So here, when I'm multiplying fractions, the first thing that goes through my head is fraction times fraction. I'm looking for an opportunity to cross reduce. I'm looking here at the 3 and the 2, can't do anything. 1 and 4, can't do anything. The 5 and the 2, can't do anything. 1 and the 6, can't do anything. The reason I can't do anything is because the greatest common factor is a 1. Dividing both those numbers by 1 just leaves me with the same numbers, so it's useless. All right, in that case, I go numerator times numerator and denominator times denominator. So I get 3 over 8 subtract 5 over 12. Okay. And now to do the proper subtraction, we need a common denominator. My common denominator is going to be 24. So I'll write that 24 and then 24. And then I ask myself, what did I do to the 8 to get to 24? Multiplied by 3. So then the 3 has to multiply by 3, which is 9. What did I do to 12 to get 24? Doubled it. What do I do to the 5? Doubled it. So now I'm subtracting 10 from 9. And the final answer equal -1 over 24. All right. Find the root of the equation below here. Express your answer as a fraction in lowest terms when necessary. So I don't want you converting to decimals. So express our fractions, our answers, if they're fractions, in lowest terms. Improper fraction, just reduce it. How do you reduce it? By finding the greatest common factor between the two numbers, the numerator and denominator. Divide both of them by the greatest common factor. All right, so here we have distributive property. You know what, guys? I think I'll go over learning goals in a second. So distributive property is something we did cover in the last test. 2 times x here is 2x. 2 times the positive 5 is 10. And then we distribute the positive 3. Remember to take the sign with you when you distribute that. So it's positive 3 times x, so it's positive 3x. Positive 3 times -2, -6, equal 10. I'm going to collect like terms now. So this 2x and the 3x, if I add those together, I get 5x. And if I add the 10 plus -6, that's a positive 4, equal 10. Now I want to switch teams, change jerseys. I want to show that by writing 10. Why am I writing the 10 there? I could do some mental math. I don't need to, but it's important to show your work. Someone should be able to look at your question and see the communication, right? They should understand your step-by-step what you did. We could skip a few things, but this is one that I like to see. So the fact that you switch teams, change jerseys, by the way, you don't have to write the arrow. I just want to see that you wrote 5x equal 10 minus 4. That shows that you know we're subtracting 4 from both sides. Then we get 5x equals 6. Divide both sides by 5. X equals 6 over 5. Okay. Now the original question asked us to check our answer. I highlighted it in yellow so I don't forget. To check the answer to that question, we should be doing it for both. I'm actually going to check it down here. So if you don't mind, I'm going to skip over the learning goal for a moment. I'll come back to it. And I pre-populated this so that the video doesn't have to be, 15 minutes long. So I wrote the original question. Whenever you're doing a check, write the original question down. And now I have to sub in. And the answer was 6 over 5. So I'm actually going to sub in 6 over 5 wherever there's an x to see if that makes the equation true. Okay. So let me start doing some math in the brackets. The common denominator here is going to be 5, but my plus 5 here has an invisible denominator 1. What do? I have to make the 1 a 5. So I multiplied by 5. And then the numerator 5, that plus 5, has to also be multiplied by 5. So we end up with 6/5 plus 25 over 5 plus 3 times 6 over 5 minus the invisible denominator 1 multiplies by 5. The 2 multiplies by 5, it becomes 10 equal 10. Let's clean up the brackets. 2, and this is 31 over 5 plus 3 times negative 4 over 5, because 6 minus 10 is negative 4 equal 10. And then if I double this, 2 times 31, remember the 2 outside is a numerator. So it multiplies by the 31. So it's 62 over 5 plus, oops, in this case, it's a positive times a negative. So instead of writing plus negative, I'm just going to write minus 12. That didn't come out. Over 5 equal 10. This is getting a little glitchy on me for some reason. Doesn't like it. Okay, so 62 minus 12 is really 50 over 5, which is equal to 10. So we say 10 equals 10. Left side equals right side. Okay, so left side equals right side. That means that we've definitely solved this correctly. That's how you do your check. I'm not going to do a check with the next one just because you know what to do there. You can do that one on your own if you like. We're going to do distributive property though again. 4 times the m is 4m. 4 times negative 1 is negative 4 equal negative 2 times 3m is negative 6m, and negative 2 times positive 5 is negative 10. Now we have variables on both sides of the equation and we want to get them on the same team. So let's do switch teams, change jerseys in one shot here. So we're going to take the negative 6 and bring it to the left side team. And we'll take the negative 4 and bring it to the right side team. So what that looks like, to show my work, I'm going to have 4m plus 6m equal negative 10 plus 4. So you notice the plus 4 and the plus 6, those switch teams and they change their sign. I'm showing my work so someone could follow my steps. That becomes 10m equal negative 6. Divide both sides by 10. M equal negative 6 over 10. But the greatest common factor is 2. So the answer is actually divide that by 2 is 3. Divide that by 2 is 5. My answer is negative 3/5. Again, you can check your answer by plugging that in. Let's look at the learning goals for today. The same as last day, basically, but you're solving an equation with multiple terms. Collect the variables on one side and the constants on the other. That's exactly what we did with this question right here for letter B. We brought all the variable m's, the m's on the left side, and the constants with no variables on the right. If brackets are involved, you may need to use the distributive property. We just did that. We did the distributive property and expanded, and then we solved by collecting like terms, switching teams, changing jerseys, getting the variables together, equal whatever, and then reducing our fraction if we have a fraction. To check your answer, remember, start with the original equation. Write the original equation first, then do the subbing in. Show your work, okay? And if you made a mistake, if left side doesn't equal right side, if you get negative 10 equal 5, you made a mistake. You got to go back, find out where your error is. The good news is that once you do find where your error is and you get left side equal right side, you have the confidence moving on saying, yeah, I got that question right. Easy marks. and you know you've got the strategy down. Okay, to find the root of the equation with this one, you might want to pause the video, try it on your own. But basically in this is the situation where I would allow decimals, and it's okay because the question starts with decimals. So again, just distributive property, 3 times 2.5, right, is 7.5x because it's 3 times 2.5x minus 3.3 equal 2 times 5.2 would be 10.4. And 2 times negative 3.3x would be negative 6.6x. Now we want to switch teams, change jerseys again, and get the x's on the same side. So this negative 6.6x is going to come over, and then the negative 3.3 as a constant is going to go over to that side. What does that look like? It looks like 7.5x plus 6.6x equal 10.4 plus 3.3. You notice whenever I write something down, I wrote the 7.5x first because he was on the left side team first. The 10.4 was on the right side team first. So I wrote it and then the 3.3 came over. That's just a method I use. You don't have to do it that way. But if you get methodical about how you do your work, it ends up being a good routine and the questions kind of flow quickly. All right. So 7 plus 6, 13, and then the 0.5 plus the 0.6 is 1.1. So that's 14.1x equal 13.7. So far, a lot of mental math. And then we get x equal 13.7 divided by 14.1. Because we're using decimals, it's not good to have decimals. You're dividing decimals. So 13.7 divided by 14.1. It's like a fraction with decimals. Kind of fractions are decimals or decimals are fractions. So it's kind of weird. We can round this. If you divide 13.7 divided by 14.1 and you round to the nearest 10th, in this case, it's about 1.0. How do you show about in math? Just put a dot above the equal sign. Okay. Now, if you're doing a question on a test like that, normally it's a round answers to one decimal place. If you're not sure, you can put 13.7 divided by 14.1 or about 1.0. That's fine as well. That's how it is rounded to the nearest 10th. This last question is kind of interesting. It's an isosceles triangle. Remember, whenever you have diagrams like this, don't trust the diagram, right? This could be, for all I know, that could be a 90-degree angle, right? We don't assume that drawings were drawn to scale. So in this case, we have a word problem and they gave us an image. We're just going to use the image, but it doesn't mean the angles are exact when you look at it. Right? You can't take out a protractor, measure it, and the photocopy or on the handout is going to be exact. That's not true. So a family of isosceles triangles has the property, right? They don't own physical property. What it means is it has this characteristic about it, right? That the two equal angles, well, we know the two equal angles are these angles down below. Those two equal angles are each half the value of the third angle. That means that angle at the top, the third angle, right? If you think about that, if the yellow ones there are half of the third one, half of the red one, then by logic, the red one is double the yellow one, right? The red one is double those, or they're half of it. So either way you want to think about it. I like to think of the one at the top being double. And the reason why is, it's just simple math, right? I can call this 1/2 and call that 1, for example, or I can call this, we don't know it's actually a half. I could call the top angle, I can call the bottom angle half of x, or x divided by 2, and call that one x. But if you think about the upper one, the top and the third angle as double the yellow angle, then what I'm going to do is I'm going to call this one 2x, and then I'll just call this x and this x, right? The yellow angle is still half of the third angle in this case. Find the measures of the angles. Okay, those no problem. I know 2x plus x has to equal 180 degrees because the angles in a triangle add up to 180. 2x plus x is 4x equal 180 degrees. And if you look on Edsby, by the way, I've got a really nice handout for you there. Divide both sides by 4, x equal 45 degrees because 45 and 45 is 90, and 90 twice is 180. So x is 45, but you're not done answering the question because we also have to solve for the third angle, which is double x, which is 90 degrees. Hey, that does not look like a 90-degree angle, right? But again, we're not trusting the drawing. We're just doing the math according to the question. The drawing is just an example to help you sketch something and understand what the question is asking, but those are answers, okay? So therefore, each of the equal angles is 45 degrees, and the third angle is 90 degrees. Hope that lesson was good for you. Get to the homework now, and we'll see you guys in class. Take care.